Okay, so I'm going to show you a couple of examples of how to do molarity problems. So let's get started. Remember that molarity means moles per liter. So M, the capital M, like in this example right here, is equal to moles per liter. Okay. So whenever you do problems in chemistry, I always say to start with what you're given and put it over 1. And in this problem, we have 1.5 liters of a 3 molar solution of HNO3, which is nitric acid. And so the first thing I'm going to do, number 1, is to put my 1.5 liters over 1. And then we're going to use our conversion factors, our equalities, so we can use the factor label method. And so I'm looking in this question, they want to know how many grams. So I'm going from liters to grams. And so I need to think about what equalities, what conversion factors can I use to get from liters to grams using what we're given up here, which is molarity, moles per liter. And so we know one of our conversion factors is going to be 3 moles of solution per 1 liter. And so the first thing I'm going to do is use that as my conversion factor, because then I can cancel out liters. So 3 moles over 1 liter. Okay. Now, how do I get from moles to grams? Well, I'm going to use my molar mass. Molar mass of HNO3 is 60.01 grams of HNO3 per mole, right, of HNO3. And so I'm going to use that as my conversion factor to get to grams. So 60.01 grams of HNO3 over 1 mole. And now all we have to do is multiply through. So we multiply 1.5 times 3 times 60, and we get 270 grams, because we cancel. So look, we cancel liters, we cancel moles, and we're left with grams. And that's what we're looking for. And that's why it's always the best to do these using conversion factors in the factor label method, because you know that you set it up right. If you can cancel out all of the other factors, all of the other units, and you're left with what you're looking for, you've done it right. So, we're left with 270 grams of HNO3. And there's your answer. Now, this next one is a little bit different. We're still going to use the same thing. We're going to start out putting what we're given over 1. And so this one is asking, what is the molarity? So we need moles per liter, right? However, our volume of the solution is 0.5 liters. And they're starting out giving us grams of NaCl, right? So we're going to, again, start with what we're given and put it over 1. And so 205 grams of NaCl, right, over 1. And there's different ways you can do this. This is just, I think, the easiest way. One way, maybe you know an easier way. So now remember we have to get to moles per liter because we're looking for molarity. So we need to go from grams to moles. And again, we're going to use the molar mass. And so the molar mass of sodium chloride is 58.4 grams. Now, this time we need to get rid of grams. So we're going to put 1 mole on top because that's what we need to convert to. 1 mole over 58.44 grams. So 1 mole of NaCl over 58.44 grams NaCl. And remember, this is just the molar mass. Right? So at this point, we can go ahead and multiply through, divide. So we have 205, I'm sorry, 205 grams, 205 grams of NaCl. And remember, grams cancel, so that's not grams. So we have 205 moles, of NaCl divided by 58.44, and we cancel grams, so we don't need to put anything there. And so our answer, and I didn't calculate this out yet, so our answer is, you're probably going to get this faster than me, divided by 58.44 is 3.5. So we have 3.5 moles of NaCl. Okay, now we need moles per liter, and we know that we have 0.5 liters. So now all we have to do is take this answer, and remember, molarity is moles per liter, so we're going to take this answer and we're going to divide it by 0.5. So 3.5 divided by 0.5 liters, 3.5 moles divided by 0.5 liters is 7. So we have 7 moles per liter, or we can write it as 7 capital M for molarity. And that's the practice problems on molarity.